Hey everybody, this is Larry. This is me going over what week is this? Is this week 3? Week 2 of the Leetcode weekly premium challenge. Hit the like button, hit the subscribe button, drop me on Discord. Let me know what you think about this farm. So this one I struggled a lot. I end up spending about an hour and a half on this one, which I hope teaches or shows you a couple of things. One is that greedy farms are hard. Even though I knew it was greedy and I was playing around with some greedy things, it still took me a long time. And because of the length of the thing, I'm just going to go over the explanation now. You could watch the live portion of it, afterwards. But it's very long. So and I kind of stumbled on a lot of cases. And then the other thing is that, sometimes it takes a long time to grind, and I was just missing that one observation on this particular piece that I wasn't able to get it and this is kind of an implementation detail, but maybe I just didn't really thought about it quite precisely. So the key thing about this particular problem is that there are at least two big edge cases, as I call them. There's another one that is kind of a variation on this, but the idea here is that I'm looking at here is that you can't do just like a simple bucketing thing, because let's say you want to bucket by 2 and then you have A, B, A, B, A, B, and then at the end you're going to leave with all C's, and the right answer is to spread out the C's. And I kind of just didn't have any ideas after a while, and I just kind of tried something that worked, and then I had to readjust until I kind of saw a light bulb kind of thing. And then the second case is you can't just do ABC, ABC, ABC and interleave them, because you can have this one where you have half A's, a quarter B, a quarter C, and we do that, then you're going to have a lot of A's left over, right? And then there's some weird cases as well, but those are the two major ones. So to be honest, I did knew that it was a heap and greedy with respect to a heap right away, but I kind of went about it the wrong way. I thought that, for example, in a greedy kind of way, if or I didn't know how to enforce the k distance away part. It took me a while, to be frank, because I thought that one way to enforce it is just to force it that if an A is in slot 1, then the next slot it can be is at 8, and then so forth. So we keep on kind of jumping it that way. Unfortunately, that's not necessary, or that's not. That will lead to a wrong answer, because you kind of lock certain things in certain slots, as I call them. But I couldn't disprove it during the live solve until I got a wrong answer that showed me a case that was wrong. But yeah, and then it took me a while. But then the flashlight or the light bulb or whatever is just thinking about these as defense, as we kind of have a heap. So basically, if you use this, we have an ongoing heap, and with this heap, we choose the character that has the most frequency every time. Because if it has the most frequency, then it means that we have to do it as early as possible, in theory, right? Because in a greedy kind of way, otherwise you may have extra stuff, and this is one way to kind of handle it. For example, if you have ABA, you have to do the A first, because that's the only way you'll fit, right? So given that, the way that to think about it ultimately is to think about it as, like I said, time defense. So let's go over the code real quick as to what I mean. So here I'm just saying if k is too big, we don't have enough alphabets, it's empty. If k is 0, then we just return s, because there's no requirement basically. Otherwise, this is basically saying we have if one character appears more times than we have slots for, then we just return empty string. It's also impossible. I think now after the rewrite this isn't necessary, but I put it in. Otherwise, we do a max heap on the frequency and the key. And it's easy to kind of dismiss the key as a tiebreaker, but you actually need to know this key as a tiebreaker, because basically, is that true? I think it's True. No, actually, maybe you don't actually. Maybe I'm wrong, but it does make it easier to think about. So yeah, so the idea here is for me is just to have basically a defense queue, right? The idea here is that so every time we go through one character, we pop off the heap, get the count, get the key, we append the key as in a greedy way, and we subtract the count. If there's any count left, of course we just put it on the queue instead of putting it immediately in the heap. And what I'm putting on the queue is the time event that okay, we can use this key again in I plus k quote unquote time. And so now this key is out of this heap until I plus k. And that's basically the idea here, is that here when I plus k is the new I, we able to pop left from this queue, this event queue, and push into the heap. And then you keep going, and if we run out of characters for the current one, that means that you just have too many things and not enough characters now in a greedy way, so then you can return empty string. That's pretty much it. This part is going to be where A is the size of the alphabet, or 26. This is going to be A log A, but the rest of it is going to be N log A, because you have an N loop and a couple of heap calls, and then everything else is going to be O of 1. So yeah, in terms of space, we have O of N, that's the size of the output, and you have an A for both the heap and the queue. Both of them are going to be just O of A time, or O of A space. So yeah, that's it. That's all I have with this one. Let me know what you think, and yeah, and you can watch me solve it live next. It was such a struggle. Maybe I'm just having one of those days, I don't know. But give me some support, hit the like button if you like the fact that Larry spent an hour and a half on this problem. I'm so tired. Later, bye-bye. Hey everybody, this is Larry. Let's take a look at week two of the September Leetcode weekly challenge, premium weekly challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. 358, rearrange string k distance apart. I have not solved it yet, so I'm super excited. As excited as you can get to in Leetcode. Given a string s and an integer k, rearrange s such that the same characters are at least distance k from each other. If it is not possible to rearrange the string, return an empty string. Same characters are at least k distance from each other. Okay. N is pretty big, so you have to be a little bit careful. I think greedy is probably the way to go. To be honest, right now I'm trying to think whether that's true. I think there's something about greedy, but I think I worried a little bit with. Oh wait, no, k is the constant, so I think greedy should be good. Because if a character appears, for some reason I thought that you may try to minimax, but if either it's possible or it is not, right? And so there are only 26 characters, but even if that's not true, you would always greedy k distance away from each other, and then you space them out. If you have too many characters, it doesn't matter how many you have, and if you don't have enough characters, then you could also just kind of squeeze stuff in the back. But I think, okay, so when I say greedy, I guess there is some nuance to that one, because for example, if you're not careful and let's say, so what I try to do, especially with greedy problems, is to think about the counter cases, right? So let's say k is equal to 2, and you have a lot of A's, a lot of B's, and a lot of C's, enough, right? And if you're not careful about the greedy, you can have A, B, A, B, A, B, A, B, A, B, A, B, and then by the time you get to the end, you do C's, and you're like, well, no, you definitely could have done a little bit better. You could put C here, right? So I think it's still greedy, but you have to be a little bit careful. Is interleaving enough? Like, is it okay enough to just interleave? I mean, no, not exactly, because let's say let's say k is equal to, I don't know. Well, also just like 3, right? Or whatever, 2. and you have the same thing, except for now it's a lot of A's. Let's say a quarter B and a quarter C. Then you want A, B, A, B, and then A, C, A, C, right? So you don't want, because if you just do A, B, C, or A, B, C, A, B, C, A, B, C, you're going to run out at the end, and then you're just going to have a lot of A's, which obviously is not K distance apart. So we have to be a little bit. So it is probably going to be greedy, but maybe I'm wrong. They're definitely, these are the two quote unquote easy, obvious, greedy solutions that are also, you could see that came up with a counter example pretty quickly. So we have to be a little bit careful. I mean, I think the way to think about it is that true? Yeah, okay. I think that's true. The way to think about it is that you're given buckets, each of size K. And then you're trying to figure out how to bucket them in a way that is except for the last one, right? Because the last bucket, it may not be, like it might not go into evenly, which actually may actually be a little bit difficult. Let me think about this. There are only 26 characters, so the next thing that I'm thinking about is there a way to abuse the fact that the alphabet is only 26 characters? I think intuitively it still should be greedy. I think the bucket thing makes sense. I'm just trying to think about edge cases. The reason why the bucket thing makes sense is that you would always put the same thing in the same slot anyway, unless you change characters, so then that would be fine. Unless, yeah, unless this, I mean, that would be fine if the length of n, or length of s, which is n, k divides that equally or evenly. But if it doesn't, then I think it still should be okay, because then you could, for all purposes, you can rearrange all the other ones without loss of generality, and you only, so the two extra ones will be whatever you want it to be anyway. I think it should be okay, but yeah, so then, okay, let's say we have K buckets, right? Then now, what it changed to is just greedy, right? If it's greedy, then we want the maximum things in the front. Yeah. I mean, okay. I mean, I think this is now an implementation problem, which is not necessarily that much easier. But, yeah, so let's say, maybe we don't even need this per se. Let's say we have f is equal to, now we have a frequency table lookup for the string s. And then now we want to sort by the values, almost like a heap, right? And you just kind of keep on ticking things off the top. But you have to be a little bit careful. Or maybe even a lot careful. But I think it should be okay because everything will be forced. But I don't know. I don't know that that's true. Maybe I could do the mod on the... Okay. Maybe that makes it a little bit better, actually. Okay. So I think the easier thing is, for me, is... Because I was worried about, like, getting to an inconsistent state by the time you get to the the what I call the remainders, the leftovers, basically n mod k, right? So leftovers is equal to n mod k, right? Because in theory you can force like a bad example or bad thing where they're less than k apart. But I think if you just start with the leftovers, you should be okay. So okay. This is very annoying to code. I think implementation wise, I think it should be okay. I think I'm more convinced algorithmically, but also to be honest, I think lately I've been pretty good algo. Like I'm not pretty good, but like pretty good for myself. But my implementation has not matched that level of goodness, so it's been the thing that's been messing me up a bit recently. So okay. So let's just put everything in a heap. So for k and f dot keys, let's call it key because also let's make this uppercase k because I feel like I make this mistake a lot where um, we use it or whatever. But yeah, so then you have and key. So then let's put in a heap because I'm lazy. And this is a in Python, this is a min heap, so actually we want a max heap, which is kind of annoying to do, but we'll do it this way, right? Okay, and then now we'll just first take over the leftovers, right? And basically, the thing is that we have to, the thing I'm thinking in my head, which I didn't talk about, is that every character is locked into the character they were initially drafted in, right? Because yeah, is that good? Okay, so there's even without. Let's say you want to put in another one. Yeah, I mean, I think that should make sense, but the reason is because you want to maintain this k distant thing, and if you make them exactly k, so like in the same slot, quote unquote, then it should be good. I'm still worried a little bit. No, because you can only fill into a new one if you were new. I don't. No, I think I'm wrong. I think that's what this is, the bucket of K idea, right? Yeah, maybe I am wrong on this one actually. I think I confused myself a little bit. Because I think this is the case where we try to bucket it by K as you go to 2. You know, if everything is a third, then you just want ABC, ABC, ABC. Right? Huh. How do I do this one then? Maybe, is it greedy? Okay. I'm very wrong on this one. Sorry, friends. Um, I think I just forgot about. Oh, I didn't forget about it, but I think I was trying to. Rubbing my eyes too much. How did I address this case? Is it always possible if no numbers is more than n divided by k? Hmm. I take that back. I'm not that good algorithmically as well. But at least we corrected before I got any further. But well, if k is greater than the size of the alphabet, no, that's not a good idea. Because wow, this is a hard one. Uh, hmm. So there are really two scenarios. One is either it's greedy and I'm have to figure out how to do it greedy in a good way, or it's like a case analysis problem, which means that you break it into like, well, different cases, and then for each different cases, they do certain things. And it's not clear to me that greedy problems basically has this um, substructure where whatever decision you make, it makes it optimal, right? But like between here and here, when we get to the C's, how do we decide to go either at the end or just in the beginning, right? Man, this is tough. So K has to be less than the number of alphabets for obvious reasons. Because if K is too big, then it's not possible. But this is, for a small K. So, yeah. If length of F is less than K, then we return, is it empty string? Okay. Otherwise, what do we do? How do we address this one? So that it goes ABC, ABC, ABC. Because the answer is obviously, it is obviously not to interleave, which is how we got to this thing. But still, trying to think is still, take when I say taking advantage of n is or not n, this alphabet is you go to 26. Trying to figure out if there's a thing to abuse, like can we brute force for certain characters, or not brute force, but like, you know, like maybe I don't know, like the prefix has some different rules than the suffix or something like this, but. And Maybe I shouldn't do these tired. But can I be greedy? Okay, for k is equal to 2, this is only a concern if one thing is like close to n over 2. Right, for the thing. For k is equal to 3, you could have 2 strings that are kind of like that, or 3, I guess, with all n is less than, or n is equal to 3. And you could have some like crazy interleaving where it's like ABC, 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 and then ABD, AB, ABCD maybe even, and then ABCD, ABCD, ABD, 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 or something like this. I guess you would just move. Now you need these to. You need these to keep it 3 apart, but this would be 4 apart in the middle. Right? Something like that would be possible. Huh. I'm stumped. I don't have an idea. I mean, I have the counter cases. And you could see that here, the bucket row is just definitely not true. Though, because some of these has a bucket of 4, if you want to call it that. And even if you move them to the back, which is fine, I guess. I think I missed a B here, that's why I got a little confused. Well, maybe I just deleted by accident. Like, even if you move these to the back, just for purpose, like, it doesn't change anything. You just have buckets of 4, and not with respect to the leftover idea that we had. Right? Huh. Alright, well, I have no idea. In 20 minutes in, I don't even have a concept. So maybe my algo isn't that good either. Let's see. Is there anything else I can play? I don't know if there's anything else I can play around with. This could be the case, maybe, but I think maybe I just have to do it this way with the bucket of K thing, and then if we have extra, we just kind of keep on adding it between stuff because by definition they're good. And because by definition, or at least if that's not the case, then we're wrong anyway. But then the less than, okay, the leftovers idea again, maybe? because for the leftovers bucket, you want the idea behind the leftovers bucket is that you want to greedily choose the ones that are in the front. Okay, I think that's fine. Okay, I think maybe that's it. Maybe we just do it with the bucket idea, and then if we have stuff left over, we just have to we can insert them in the, because by definition the earlier buckets would already have. Yeah, we'll just have to do it buckets by buckets. Okay. Okay. Yeah, okay, fine. I think I don't know if this is proof. I don't know if this is even correct, but when you have nothing else to go on, I think it's you have to do the grind. You have to try everything out and see where you're wrong. And learning is not just about getting it right and then learn from getting it right, but it's also about doing something that's possibly wrong and figure out why it's wrong and learning that is wrong. So we'll figure it out. Okay, fine. Okay, and then right. So, how am I gonna represent this? I guess what I really want is a sort of like an array that we can keep on inserting stuff in the middle, but maybe that's fine. Maybe this is fine. Yeah, let's get something instead of trying to overthink and over optimize in my head. Yeah. I'm gonna do the other thing as well. Set up the heap. This we already talked about. And then here, I guess look up heap q dot heap pop. Also, I think I messed this up. Well, this is the leftovers is what we're gonna put at the end, I guess, not at the beginning. But with the visualize is a little bit funky. Okay, fine. Okay. So count and key is equal to this. Make sure we convert it to the right thing. And then now lookup of key is equal to I. And basically, this is just gonna stuff we put at the end. So let's just call it the end. Maybe I'm a little bit lazy on the naming. Yeah. And then the end dot append key. We want to do something like and then put it back in. Yeah, okay, fine. We'll have to push all this stuff back together later. Maybe. Okay, yeah. So then now, this is kind of yucky. For key in the end. Oh, wait. basically we want to put it back into the heap, but we don't want to do it just yet because then you may get the same key. So yeah, let's just say to process maybe. We'll just have to remember do it. This is kind of messy as hell. What is it? Key count, right? And then now for key count into process, decrement, and then hit Q, hit push, keep the count, and then the key. Yeah, okay. So then now we have stuff in at the end and stuff in lookup, right? So let's print lookup real quick, just so that it is exactly what we think it is, maybe. That divides equally. 3 is 2 mod whatever, so that should be good. And yeah, this is evenly again, so we might have to put in our own test cases, which is these ones. Let's do that actually. So let's just say k is equal to 2, and we have say 10a, yeah, 10 A's, 5 B's, 5 C's, and then the same thing, but now we have, oh no, I think I did this one by accident. What we want is actually multiple of 6, is it? So A, B, B, C, C, but maybe just a little bit longer. Right? Run it real quick. Yeah. So then the answer, like we said, is going to be, oh yeah, this is the divided one, and then this is the alternating one, right? All right. This is actually a mess, but all right. So now we have to do it bucket by bucket. Here's the bucket. This is so hard. How do you know to collect them later? I mean, you could do checks, but it's just so messy. Yeah, so that's what it is. Just have to do it. Okay, so now for the first bucket. Okay, so basically we have this idea of the current bucket, right? And then now we'll fill it out from to K, right? This is fine, but we also want maybe like reverse lookup. I don't know if it's a reverse lookup or just normal lookup, but what did I? Oh, I made it really small for some reason. Okay, whoops. But yeah, maybe this is a little bit better. Maybe I don't need this. Maybe I do. I don't know. Right. And then basically now, okay. So here for each K, we look at the all lookup of I, right? with this heap thing, but what we actually also want is maybe f of key decrement so that we have it in two places, because then now we can do a lookup of, you know, if is greater than 0, then we can just put it in, right? Else we have to, else we will take one from the heap, because that means that we ran out of numbers. Oh yeah, ran out of things for this one. What is it? H. And then now here, this is what we want to use. So then now we want to replace all lookup of I is equal to key. We subtract 1 for using it now. We also update decrement and then push it back. But then we can append key, right? Okay, I mean this isn't complete, but this should be okay. So while length of f is greater than 0, this should happen. I think the only time this is false is if it is impossible, which is if, or yeah, but I should just check for that, right? So yeah. No, that's mathematically impossible. So okay, let's see. So I can do actually something like if max of f dot values times k is, I mean, it's something like this, but we have to be a little bit careful with the off by ones, because if you have 3 characters and k is 2, then this will be 2 plus 2 times 2 is 4, but n is 3, and this should be true still, because you have like ABA is an example, right? So you have to be a little bit careful about this one. Is this plus I think n mod k is equal to 0 or something like this, because if this is equal to, if this is not equal to 0, then this will be true, which is a 1, and then that should be fine, right? Okay. I'm writing pretty poor code here as well. Otherwise, this should fill out, kind of. But otherwise, this is equal to 0 for some reason. Lookup of I is in F, and this. I guess I could also be lazy, to be honest. I can maybe just write this as max. It's a little bit sloppy, but it's also, there are only 26 things, so hopefully maybe that'll be fine. But let's see what that does first. Okay. All lookups of I. What was the error? Index of. All lookup. Oh, I only did it for the leftovers. So, actually it should be, let's just say none times k. Yeah. Is it infinite loop? Oh, I didn't decrement here. So all f Okay. I don't print anything at all. Oh, and then insert out a pen code. So the first one I expect to be, actually did not expect, oh no, it's K0 I expect this one to be wrong. Oh no, the other one, because I think I put it in the reverse order. How did this happen? C got 0? How did this happen? So this is mostly right, actually. Oh, no, is it? Oh, no. It's just that it appends more A's than possible. I think... Why is A still in here? Oh, I think we just don't need to push it back. I think that's why. Okay, because I already put it in the offovers. Okay. So then, because I actually expected this to give me an error. That's why I was confused. I still expect this to give me an error, so... because we shouldn't have any characters left. We don't put it back in. Oh, we do put it back in here for some reason. I think that's a little bit confusing. Well, I was inconsistent with how I thought about it. Okay, so this is giving me an index of range error, which is expected. So then, yeah. Okay, that's good. That's good, actually. Or it is what we expect for now, so I could build off it. Okay. Good. But then now I can see what it's giving me. And this should give me a lot of nuns. Okay. Yeah. Okay. Then the other ones is just actually... Yeah, the other ones are right, I think. We just have to concatenate them, and we also have to concatenate the n, I think. So... I don't think we have one with leftovers except for this one, but then it's just impossible, is what they say. So we need to put in a test case. Let's choose ABA and 2 for now. See what it gives us. This is not great. That's a little bit awkward. I thought I decremented here. Oh, I didn't decrement it here. I kind of did some funky stuff, but I didn't even... This count doesn't even matter. Yeah, okay. Okay, this is what we expect, though. I guess I messed it wrong. I think append, not extend, that's why. Okay. And maybe only if length is greater than 0. Alright, and then now we just have to join them, and we're mostly right. May not be 100% right, because we didn't intend to this case. So let's join them really quickly to see whether we, just to kind of play, just to enjoy ourselves. Yeah. Right, yeah, so for... I code, let's just... What did I code? Bucket? In answer, or dot append, bucket, and then, yeah. This should give me an error about, like, something about the nuns on 6 or something, or whatever, problem 6. I kind of knew that, so let's just say if none in bucket, or not in bucket, whoops, just to kind of see what's up. Okay, so we're all good in all those cases except for this one, but we expected this, right? We're getting the C and the none, and then now we're able to kind of redistribute the nuns, or the ones with the nuns, because by definition, I think I just have to be really careful here. It's all. But by definition, if you use it, put it in any of the original buckets, it should be okay. I'm just a little bit. I think we have to put in the front, maybe. Maybe that's a little bit better. So yeah. So now for bucket in answer, if none in bucket, then now we take this bucket, and then for each row, we have to redistribute. How do we do it? We can actually just take. So then we can filter. Okay, for x in bucket where x is not none. If x is not none. So then this is filtered out. We could join them now, and then we want to put it into the first thing. I think I have to be careful because I'm just trying to think about the case where, let's say we have something like, I don't know if this is possible, but something like A B A B A B A B A B, and then AC, right? And if you're not careful, like if we put it, or maybe let's say we have some other funky things, right? Like say BA, 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 BA. Maybe that's a little bit different. And then now CA, CA, CA. And if we're not careful and we put like C, 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 then now the two C's are too close together. That's why I said you have to, I think you have to put it in the front. It makes it easier. But then now we have to do some like, you know, and then now we have to make sure that that's fine. But I think that's okay. So yeah. So then now, let's just say current bucket is equal to 0, say. And then now, yeah, answer of current bucket, right? Is equal to this plus something like this, maybe. Well, if I spelled correctly, right? I know that this is O of n, but we only do this once per row, so I think that should be okay. Doesn't, so it still maintains the O of n-ness, the linearness. Yeah. I think this is okay, and we go out of bounds, then that would be funky, but I don't think it's possible to go out of bounds. But maybe I'm wrong on that one, to be honest. Like, in theory, if you are able to go out of bounds, then this thing should have caught it. But also, my implementation might just be bad, so even if the idea is right, we may just be wrong. But we did get a lot of the edge cases that we all think about, or thought about. Let's give it a submit. Am I confident? Not really, but you know, we spent 45 minutes just like mucking around, so let's at least, you know, give it a go, and then at least get a wrong answer. And of course, I didn't know K could be 0. Why would K be 0? Come on, man. And I even did it even here. Come on, K is equal to 0. That I should have known, but okay, that is pretty silly though. Fine. If I think I did this wrong though. I think this should have been. No, that's not true. But come on, K is equal to 0. Fine. I think I don't know if there's a. I mean, it's my fault, but it still feels like a silly gotcha, right? Like it's unnecessary. Oh, okay. So okay, I didn't misunderstood this. K is equal to 0. I guess this. Oh, that is such a silly case. Let me think about how to handle it. I think this. I mean, without special casing it, maybe I would special case it, but what is K is equal to 0? At least K. If K is equal to 0, okay, then you just return the string, right? I think I just misunderstood what K00 means. Stop it. Alright, let's give it YOLO submit. Okay, so at least this is a legitimately wrong answer. So let's give it a spin. Like I said, I wasn't super confident about this one, but it seems like I returned whatever on this. Why do I return an empty string? K is 3. We have 4 characters, so this part is not true. So this part, right? So the max is going to be. I don't return empty string anywhere else right now, so it must be here. So max is 3. K is 3, so this is 9. We have 7 plus. Even if this is 1, it doesn't matter. So we have 8. Is that not I guess my formula was just bad. Okay. Let's just break it out. I think I try to be too clever with this formula. But I had the idea, right? Just that, yeah. Okay, so groups is equal to n divided by k. If n mod k is not equal to 0, we have an extra group. And then now if this is greater than groups, we return string. I guess I should just, maybe I tried to be too clever. With just doing everything in my head. Wow. Well, this one I'm just missing characters, which is even worse. I don't know why you have max 8 cases. But which one is the least I care about? I don't care about this one. I think that one we got. Alright, so a lot of things going wrong with this. But let's see if there is an implementation thing or algo thing. Okay. So k is equal to 3, right? We're missing a D. Why are we missing a D? We have k is equal to 3, so we have 2 nuns. So, let's take a look at before. So this is after our processing, I think, but maybe I'm just off by 1 somewhere as well. No, k is equal to 3. I think it's because leftovers is 2. I see. I don't account for the leftovers in a correct way. Or like I don't combine them in a correct way. That's tricky actually. Because I did this because the leftovers are in a greedy situation. Because we always want to put the most common characters in it. But now it's giving me issues. Because now, okay, this isn't a real thing, so I have to kind of think about it a little bit. Because basically what we're saying is that given ABCD, and then k is equal to 3, we're basically saying, okay, there are going to be 2 things leftovers, so we want to put A and the B in a greedy way, and then now we do ABC instead of just the groups, right? I think there are just too many groups here anyway, but technically we only need this if the max of f values is greater than, or if it's exactly groups, but I don't know how to express that. So okay, so we have to kind of think of, oh my god, man, what a mess this problem is. But we're almost done, maybe. Like, wasn't it, I feel like when we submitted, it told us how many cases was it, and it was like, maybe it's not here anymore. I think it was like near the end. Well, whatever. Because in this case, what we want to do is Okay, the D we go here and that's fine, or technically in the beginning. And we always put the D, and then now we have two extra things. We have a C and a D, and then now we want to put CD somewhere as well. And we actually want to put the CD in this group, which technically is just like a mess. I didn't think that that could happen. So that already, I guess technically D space C. So then now, I guess we don't need this actually. Because by the definition of how heap gets looked up, I think we'll just greedily choose this anyway. So then maybe we just don't do this. And not I think, because I think originally I thought about writing it another way, which is, I don't know. Okay. Now this is basically doing what I expected to do. But now I'm even less confident, to be honest, because I'm not sure that I handled leftovers correctly, even though I got it for that case. But let's give it a submit and see what our wrong answer is. I thought we did this one. Oh, wait, what? I thought I tested this actually. Did I remove that case? Why is this different than BBA, BAB maybe? Yeah, what the? Why does it go to the top? I mean, I get that it's max. Just let me edit my own thing. I don't know which one. I don't get why there's only 8 test cases. It's not that bad. ABA, A, and then, yeah. Oh, I see, because this is part of the leftovers and we just put it in the front lazily. And also this is wrong, but maybe I just ran it and didn't see it. Is that possible? I don't know, I have to go back to the tapes. So we cannot greedily just put it in the front. My assumption was the leftovers were going to be... Yeah, and you can't even do, like, you can't even put it in the back, right? Because if you have something just like ABA, then if you put it in the back, you're just going to have AB, which is not right. We have to handle the leftovers, but... I guess we don't have to care about this per se, but in the sense that okay, I think I got it. We don't always have to use up all the leftovers, but we have to do it for yeah. It's okay. So maybe while true, or at least length of heap is greater than 0. So we have, I don't know, heap q, or the max item. If the max, so count key is equal to this, and then make sure that we have the right count. If count is equal to groups, then we have to do something about it, and then we do this thing about lookup, right? What is k again? K could be pretty big, but if k is bigger than 26, we return an error anyway. So then we could do some k-square stuff because I'm just a little bit lazy, but none. So all lookup of this is equal to key. F of key we decrement, and What am I doing? Don't be lazy, Larry. Leftover index is equal to 0, say. Man, I am struggling today, so I don't know. What's going to do the code force bit? I need AC. I mean, I have AC, but it's not in this room, so it is very hot. That's my official temperature. Okay, so okay, and then we put it back into the heap. Do we put it back in the heap? No, we don't. All we have to do is just do this, and then that's it, because it will go decrement eventually. All right, and then that should be good, maybe. We'll see. Leftover index, what? I see, because of the, it may not be leftovers, but oh, I don't pop, that's why. I see, I see. Because we don't push it back, but we should pop. Okay. And we don't need this anymore. Sloppy, but okay. Alright, so now we're good-ish. Because now this group of things we can put in the end. So extras is extras dot append key, and then all dot append extras if oh no, not it's answer, and it's if length of extras is greater than 0. Alright, I mean, we lost some test cases, so I don't know if this is actually good anymore, but let's give it a go. Oh no. Oh, I see, because we put the extras at the end. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Did I miss the character? Oh, I did miss the character D. I thought that it was always possible, so I guess I was wrong on that one. Let's see. What do I look like? I mean, it's saying it's impossible, but and I was wrong in that. I assumed that it was always possible if. Oh no, I didn't do the case. So wrong answer today. We'll be excited to see what the right answer is. But okay, so I have to K is equal to 4, ABCD, ABC, and then we have an extra C as the leftover. Why? Oh, I didn't put in the extras yet. That's why. All right, let's print the extras real quick. We'll print it with the extras. We have 3 A's and 3 C's. We have 3, 4, 1, 2, 3, 4. And we have 2 extras. That should be okay, right? Or am I just confusing something? Oh, I see. 1, 2, 3. Okay, ABC. I thought this was not possible, but I was wrong. So I think that's basically why. Okay, so basically we have more leftovers than it is possible. Okay, so actually, let's just say we right. And then now it just has to be index again. Missed an edge case. Yikes. Man, greedy problems are hard. Okay, so now what's going on here? Oh, what? Oh yeah, I know, because it removes this and then just does ABC in the front. But the key thing is that extras have more than the leftovers. So okay, I didn't think this was possible, but I just didn't really think about this particular part enough. That's fine. Okay, then we return. Right? Oh. Oh no, not. If this is greater than leftover slot. Okay. Okay, but this one's not wrong for this one. Why? Oh, because leftovers could be 0. Wait, what? And this could be exactly even. So then now it is giving one thing as leftovers. Wait, really? But because this is a little bit wrong. How do I check for this? Man, my math is really wrong. Bad. So it all stems from like just me not knowing how to check if the extra things. Do we round up? No. Do we round down? This is the number of groups, but if it's Zico, then yeah. Okay. I think n mod k is equal to not equal to 0. Because if it's equal to 0, this doesn't make sense anyway. So, how do I feel about this? I mean, how confident was I 6 submissions ago or whatever? I don't know how much. So let's give it a submit. Oh no. Looks like this is one of those problems that I will never solve. I think the idea is kind of right, but now I'm just, I don't know. I don't think I have anything structural. I'm just being pretty dumb. Is this correct or why is this wrong? K is equal to 6. So the C is right, probably. E seems right, but why is this wrong? We don't have to return the minimum, right? Or anything. I mean, the answer is to write a checker, but I don't know. I don't see how or where this could be wrong. But I am also just maybe not a smart man. A only appears in 2 places, but that's fine, right? Maybe. Did I copy it? Okay, so I'm just lazy right now. So so C. Oh wait, I meant less than K. Okay. Okay. Well, and then not equal would be nice, but is 0 and 5? 0, 1, 2, 3, 4, 5, and we want 6. Did I just miss something? We don't have enough alphabet? Is that right? That doesn't seem right, right? Am I misunderstanding 6 correctly? Huh. Let's print out the answer. Maybe I'm just confused. Definitely confused, but I see. I have this thing, but I put it in the front. And then now this C is too close to this C. Huh. So we do greedy, and greedy is just apparently very wrong, because we have extra B's and extra J's, and probably the answer is such that this none is some other character. And then you just have C concatenating J or something like this. Though I don't know, maybe we're just off by 1 character. No, we have the right amount of characters. So I feel like I'm missing a none or something, I don't know. Or maybe I just forgot to subtract 1 somewhere and... Wait, how many leftovers are there? No, I think it's because we have 2 leftovers. Yeah, the leftover is 2, but then these things, our philosophy was that this can only contain a couple of characters, or these contain characters that are not in the thing, so then now you can just merge them, but that's clearly not true the way that we did greedy. Because we put the most common things in front. Man, honestly, I don't know. This is definitely a hard. Maybe it's not greedy. Maybe I spent an hour wasting my time on not greedy. How else would I do it? Let's see. Oh, just not greedy the right way. C, you can't merge the C with this stuff. That doesn't even make sense. So my assumption was that this would get locked in, but I think it's because we have to do some like alternating things, because I think we started off the B and the J a little bit too late, probably. Let's actually look at the heap real quick, or the frequency table rather. Yeah, and I think we started the B and the J. We have to do some like more early interleaving. Well, definitely we can, but then and move one of the characters from the earlier to this none. Like the B and the J we can put in like anywhere really. So the B and the J actually like this is fine. Is that this one we need an extra character from which I didn't consider, I suppose. I don't even know how to classify this case. Wow, that's hard. So I don't think it's greedy now. That's a case for me to kind of be convinced that even my crazy greedy is not working. but I don't really have an idea if it's not greedy, to be honest. It's not DP, it's not, or is it? Is it some sort of crazy binary shit? I don't think so. I mean, C is forced, but then all the other things can be whatever they want to be, right? So that's the tricky part. Is that BJ could be wherever, as long as it's not in one of the J's, which here is fine, or either here or here is fine. But this one means that we can we can replace, let's say H. We can put an H in here, and then I don't know, and then here is going to be good enough, or replace the H with a B or something like this, and then this with an H to make it right. I thought greedy would make sense, but maybe not. Alright. I'm convinced that greedy doesn't work, so let's, how do I think about this? I don't even know. Wow, so many submissions. Why is my finger so, I need to get some water. I was holding it off for solving this problem, but I also thought I was going to solve this like an hour ago. Okay, so this logic is fine for checking impossibility. But if it's possible, what do we do? And this is the case that yeah, let's fix this a little bit. Yeah, the C and the E, which is in here. And really, you could just move anything that's not a B or a J, but honestly, I have no idea. Am I missing something? I feel like it may still be greedy, but I'm missing an observation that ties everything together. Oh, excuse me. I mean, this was the case that I was worried about initially with greedy. That kind of like yeah. How did I do it without some kind of crazy NP complete crap? 26 characters, can we abuse that? I mean, I think my mistake was also assuming that they have to be consecutive. But I think doing the consecutive makes it easier to kind of group them together by a group. Can I do them not consecutively? Probably. That would make sense, but that's what I had initially, but I don't know that I can prove it either, to be honest. So, and I worry about the extra characters, but I guess the way that we handle it is maybe fine. Alright, let's give it a try. Alright. I thought that I think I was just being a little bit lazy the way that I did it here, because I thought that the other way we would have fewer worries. But let's think about how that would look. Okay, so say we don't care about the leftovers. All right. Alright. I think I tried to complicate things too much. Let's kind of reset this real quick. Oh, he submitted it, so it should be fine. But, well, we do want to put in the heap. Hang on. I'm a little bit lazy on the heap. Okay, fine. Alright. Maybe the greed is just to get... I think the thing I was worried about was kind of the slotting. But I think we can actually adjust for that. So okay, let's think about what that would mean. Man, I struggle with this one so much. But yeah. So then now we have n, so let's just say for right? And then now let's say let's say we have a deck. Yeah, let's have a deck, right? And then basically we pop. So count key is equal to this thing. Let's just use it, right? So n start append key, count, of course this is a max heap, so make sure you be careful, right? And then if count is greater than 0, then I want to push it back into the heap, but not actually. We actually want to append key and count, but also the index, so it's going to be I plus k or something, right? And then that should be good, right? And then if length of q is greater than 0 and q of 0, the front of the q is, if this is equal to I or greater than equal to I is fine too, I think. Then we push q dot pop front, right? So you have the thing, you have key and count, you go to this, and then you push it into the heap. With the maxness, and then now if length of heap or heap is greater than 0 or is equal to 0, then we return empty, because for some reason that's just not possible. We have to actually do these things correctly for Python's weird heap usage. Is it pop front? Am I thinking of another language? Pop left. That's clearly not right, but let's see. I plus k. Do I change I? No. Oh, it should have been the other way around. Whoops. Apparently I don't know how to code, so I think I was just trying to be too much with the edge cases. I actually had this idea like immediately, but I did miss a key observation in implementation. I think this idea is fine, but I wasn't able to prove it. That's one, because I was missing a key observation, and the observation was that I was immediately putting it back in the heap. And because while I was doing that, I was thinking like maybe you have to fix the slots, but then you don't know how to quite fix the slots in a good way. But the right way to think about this, which I did not do, is to think about it as like an event thing. I think that, like, if you think about it as a sweep line where you, the idea here is that, you start with, let's say you have 10 A's, you have, I don't know, 8 B's, 7 C's, whatever. Then as soon as you do an A, your A is now not on the heap until K spaces later. And then now A is eligible again here, or something like that, right? And I think that makes it a lot easier than the way that I was doing it. And in this way it is greedy, but and this enforces that there are at least K away. And because if you have the most character, the most frequent character, well, if you don't have anything on the heap, then it just means that it is impossible because you have too many things on the queue instead. So I don't know. It's just one of those days. So sorry, friends. What is complexity here, right? Let's see. I think the big thing is the heap. Keeping in mind that this keys is the size of the alphabet, so it's going to be log A. For A is 0 to 26, so it's going to be n log A, right? And then here, for each of the n, we also do one pop and maybe one push, and some O of 1 stuff. So this is going to be n log A again. So in total, this is going to be, oh, this is not n log A. This is A log A, but this is n log A. So yeah. So this is O of n log A time, and O of A space. Well, and O of A plus n, but yeah, because that's the size of the return, right? Whew, that's all I have for this one. I'm tired. I was going to do the code first, but I don't know what I was doing today. That's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.